This conference will now be recorded.
So today we will understand these two terms, abstraction and encapsulation. Okay, so what we'll be understanding? We'll be understanding about abstraction and encapsulation. So when I'm talking about abstraction, okay, so abstraction means basically it's a process. Okay, so it's a process of showing only the things. Okay, so it is a process about showing the things which are important for the user. Now, for example, I just switched on AC. Okay, if I just switch it on AC, I'm not worried about what are the internal details. Okay, so I'm not worried about how it will work, how the air is going to come, from where the current is passing. I'm not bothered about all those things. I'm bothered about I switched on the AC, is AC on, and am I getting fresh and cool air? That's it. Yes or no? So in the same way, abstraction is a mechanism. It's an object-oriented principle, of course. It's a mechanism which will help you out. So which will help you out in making the things to be useful. So without knowing its implementation, hiding all the details basically, hiding all the unnecessary details and showing only the things which are important. Showing only the things which are important. Okay. So it is a process of showing only the important things and hiding the unnecessary details. So this is general meaning basically. Hiding the unnecessary details. Okay, hiding the unnecessary details. So what we are doing now? So we are hiding the unnecessary details. Okay, so we are hiding the unnecessary details. So we are not involved in knowing unnecessary details. So we will just be using the details which are required for us, which are required. So it's a process of showing only the things which are important and hiding the unnecessary details. Hiding the unnecessary details. Okay, so that is what it is. Okay. Now, when I'm talking about Java programming, how Java programming applies this? This is general meaning. How Java program will apply this abstraction. That is important for us, no? So how Java program is going to apply this abstraction, right? Okay. So when I'm talking about the Java program, okay, a Java program implements implements abstraction with the help of one abstract methods. Okay, I shall write abstract classes. Okay, so what I will write now, abstract classes and abstract methods, abstract classes and abstract abstract classes and abstract methods. Okay, so we have abstract classes and abstract methods, and by the use of the interfaces, abstract classes and abstract methods, and by the use of the interfaces. Okay, now we will understand what are abstract classes and what are abstract methods. Okay, so under this I will be understanding about the abstract classes first. Okay, so what are abstract classes? So these are the classes that may have these are the classes that may have, okay, so that may have the and the methods. The methods can be the methods can be abstract also. The methods can be abstract also. The methods can be what? Abstract also. Now let's understand what are abstract methods. Abstract methods. So whenever I'm talking about abstract methods, the methods without body, the methods without body, the methods without body. Okay, right? So the methods without body, right? Okay, they are made to get overridden. They are made to get overridden. So they are made to what? They are made to get overridden. Overridden in the child class. In the child class. They are made to get overridden in the. They won't have any body. They won't have any body here, but they will be used by the child. Used by the child. See, child want only its name. Child want only its name. So child is not bothered about. Child is not bothered about what is implementation there, what is the body there. It wants only its name and the specification. That's it. Yes, understanding my point? Okay. Now we will go for the example. Okay. So whenever we are talking about the example here, so we are talking about creating abstract classes and abstract methods and using them in the child classes. How to do that? Okay. Let me go to Eclipse. Okay. Let me go to Eclipse here. Okay. So now in the previous example, if you remember, we created a class shape and all. Okay. So if you remember there, we had area method, perimeter method, circumference method. They were not having any implementation. Yes or no? Means they are the candidates to make abstract. They are the candidates to make abstract. So we can make them abstract. We can make them abstract. So how we can make them abstract, we will see. Okay, what I'll say here is I'll say abstract class shape. Okay, whenever you declare any class as abstract, it is known as the abstract class. It is known as which class? It is known as the abstract class, and in which you can have the abstract methods. Okay, then what are abstract methods? If you are creating abstract methods, okay, I will say void area, void area. Now, no need of any body, no need of any body. So simply I can write it like this. Okay, now, right. So for example, I will create which class? Abstract class. Which class I'll create here? Abstract class. Abstract class shape. Okay, abstract class shape. Now what abstract class will have? Abstract class will have abstract method. Method? Abstract method. So abstract method area. Abstract method area. Okay. Now the rule is if at all, if at all, if some class is taking this, let's say rectangle, okay, extends shape, okay, who's taking this? Rectangle is extending shape. Now what is the rule, you know? Rectangle must override this method. Rectangle must override that method. Which method? Area method. Rectangle must override which method? Area method. Compulsory. Rectangle must override which method? Must. Must override which method? Area method. If not, you will be getting the error. See what it is giving you? The type rectangle must implement the inherited abstract method area. Rectangle must implement which one? Rectangle must implement the inherited abstract method area. Yes or no? Without that, you are getting the error. You are getting the error. Understanding my point? Yes? Means what I need to do? I need to say void void area, and I need to find out the area. Logic for, what is the logic for finding the area? Okay, so what is the logic for finding the area? System.out.println length into length into breadth, length into breadth. Okay, so length into breadth, yes or no? Length into breadth. So what you have? You have the length is equal to 5, and you can also have breadth is equal to 3, something like that. Yes or no? Who is area now? Area is overridden. Area is overridden by whom? Area is overridden by the shape state. Getting my point? Okay. It is must and should. Must and should, you should implement this. Otherwise, you will get this error. Okay. When you will get this error? You will get this error. If not, will get this error. If not implemented. If not implemented, we'll get this error. If not implemented, rectangle must implement. Rectangle must implement the inherited abstract method shape dot area. Shape dot area. Yes. Am I clear? Am I crystal clear or not? Okay. If you are not doing this, you will get this error. If you are doing that, you will not get any error. Okay. Now, for example, if I say class square extends shape. Now will I get the error? Will I get the error? Yes. Why I will get the error? Because square also is extending shape. Square also is extending shape. So when square is also extending the shape, square also must implement this or not? Same thing, no? Same error. What it will say? Rectangle or a square must implement the inherited abstract method area. Will I get the same error or not? Yes or no? Square must square must implement the inherited abstract method shape dot area. Will I get the same thing or not? Yes. Okay. So that's the way you look at it. So whichever method, whichever class is taking the shape as the parent, it has to implement area. Otherwise, we cannot go forward. Am I clear? Yes. Okay. Now, same thing, but the thing changes, right? So you will have side. Area is how much? Side into side. Now side into side. Now I'll ask you a simple question. Now let's say shape is also giving me perimeter and circumference. Should they be abstract? Should they be abstract? Should they be abstract? Should they be abstract? Okay. Should they be abstract? Okay. Now I will say I will have circle. I will have circle. So I will have class circle extends, okay, extends shape again. Class circle extends shape. Now tell me which methods it may take. Area obviously. Yes, area it will take no. So you will have radius. So what is the formula here? Okay, so I will take double here. Better. So what is the formula here? Formula is going to be pi r square. So pi means 3.14 into radius into radius. Fine. Okay, cool. Now, what is the other method that circle can contain? Circumference. Okay, is circumference compulsory for square? Is circumference compulsory for rectangle? So what is not required? Circumference being abstract is not required. Why? It is not compulsory, no? Am I clear? Area abstract, reasonable. Why? Because it is common. Very good. It's a simple point. It is common. But who is not common? Circumference is not common. Circumference is only taken up by circle. So we are not keeping it as abstract. If not abstract, you should have body. You may have empty body, but that symbol should be there. Okay. Then what is the other thing? Rectangle. Now tell me about perimeter. Now tell me about perimeter. Should it be abstract or not required? Not required. Why? Circle will not have perimeter. Circle will not have perimeter. So perimeter may be common for rectangle and square, but circle will not have perimeter. Rectangle and square will not have circumference. So these are not common for all the shapes, but area is common for all the shapes. Okay, so if you think my class will be implemented by some other classes, okay, and I am going to give one compulsory method, make it abstract. Make it abstract. So this is which method? Abstract method. This is non-abstract method. You can also call them as concrete methods. Which methods? Concrete methods. Okay. Understanding my points or not? Yes. So those methods are known as what? Concrete method. So who is abstract method here in this case? This is abstract method. This is abstract method. So there is a rule. Abstract methods must be inside the abstract classes or interfaces. Abstract methods can be inside whom? Inside abstract classes or interfaces. So you cannot have abstract methods in normal classes. You cannot have abstract methods in normal class. Understanding my point? Am I clear? Am I clear in my points or not? Yes? Okay. Now here one more thing that we need to observe is abstract class can have abstract class may have abstract class may have none or more, not one, none or more, zero or more. Okay, I'll say zero or more abstract method. Zero or more abstract. It is not that compulsory it should have abstract method. If abstract methods are not there, no need to worry. Getting my point? So there is no restriction as such. Abstract class must have abstract method. There is no restriction. You can have zero to abstract, zero to more abstract methods. Now, for example, Inca. Okay. Now, for example, if I am saying I have an abstract class, so in that abstract class, I have total of 5 methods. Total of how many methods? 5 methods. In that, let's say 3 are abstract. In that, let's say 3 are abstract. So now, 3 are which methods? 3 are abstract methods. Now, 3 out of 5. 3 out of 5. So 3 out of 5 means, okay, sorry. So 3 out of 5 means you are going for the percentage. What is the percentage? 60%. So what I can say? 60% abstraction. How much abstraction? 60% abstraction. So 3 out of 5 methods are abstract. So how much abstraction is achieved? 60% abstraction is achieved. Yes? Yes or no? Okay. Understanding my point? So how much abstraction is guaranteed by abstract class? 60%. Okay. Now take one more. Now let's say 1 out of 5 methods is abstract. Then 20% abstraction, isn't it? Now there are 0 out of 5 are abstract. Then obviously 0% abstract. Means what I want to say here is abstract class will give you, okay, abstract class will give you 0 to 100%, 0% to 100% abstraction, 0% to 100% abstraction. Okay, So you cannot guarantee 0% every time. You cannot guarantee 100% every time. So it all depends on how many abstract methods you have. That's it. There can be zero. Zero means 0% abstract. Everything can be abstract. Now, for example, 5 out of 5 are abstract. Then how much percent? 100% abstract. So I can range from 0 to 100%. Understanding? Okay. But the question is, now as 100% is not achieved, 100% is not achieved. See, is 100% achieved? Can you guarantee 100% is achieved every time? No, you can't guarantee. Then you are violating, no? You are violating the rule. Abstraction should be there means you are violating the rule. 100% abstraction should come. So if you want 100% abstraction, you can go for interfaces. You can go for the concept of what? Interfaces. So you can go for the concept of interfaces. Okay. So go for the concept of interfaces. Then what are interfaces? They are the class-like elements. They are the class-like elements that contain public, static, final variables, public, static, final variables, and public abstract methods. Compulsory. That will contain variables will be there, data will be there, but the data will be what? Public, static, and final. There will be abstract methods. What are abstract methods will be? Public. And methods being abstract is compulsory. Methods being abstract is compulsory. So the methods in them will be abstract no matter what. Will be abstract. So if you give also, if you don't give also, doesn't matter. They will be abstract. Yes? Okay. Now I think static and final are not covered, right? Okay, abstract methods just now we covered. Okay. So we will talk about static and final in 2 minutes, but let's create an interface. Interfaces are created using the interface keyword. Using which keyword? Interface keyword, and are implemented and are inherited, I will say, and are inherited using the implements keyword. Using the implements keyword. So what it is? How it is inherited? It is inherited with the help of the implements keyword. Which keywords are? Implements keyword. Okay, so implements keyword. Okay, so interfaces are created using the interface keyword and are inherited using implements keyword. Okay, right. So how we are going to create them? Right. So we are going to create them using interface. So interface. Okay, so interface name. Interface, just like a class, just like a class. And you will have which methods I said, which variables I said, public static final variables, public static final variables, and public abstract methods. Abstract method means no body, obviously. Abstract methods means no body will be there. Yes, public static final variables and public abstract methods. Am I clear? Yes? Okay. We will go for, okay, so this is syntax basically. Okay, so we'll go for the example. Right, so we'll create an interface. So we will create an interface. Now this shape cannot be an interface. Why shape cannot be an interface? Because there are non-abstract methods also, right? So that is why what we will do is, so we will create a normal one. Interface, okay, I'll just say one. interface 1. Okay. So now, for example, if I am creating int x is equal to 5. Okay. Int y is equal to 3. Now, what are these variables automatically? They are, okay, now if you observe here, they automatically become public, static and final. Okay, let me write this. Okay, otherwise I'll just finish that definition also. I will say void method. Okay, void method. You created an interface. Okay, now in this interface you observe. S means what? S means static. S means static. F means final. S means static. F means final. Okay, here A means abstract. It is as simple as that. Now, did we put anywhere public, static, final and all? No. Automatically they will come. Okay, what a compiler will do? So, compiler will give you interface 1 and it will say public, static, final, int x is equal to 5. Again, public, static, final, int is equal to 3. Okay, and what is the method name? Public abstract void method. Done. So in this way, the things will happen. Understanding my point? So this is how we are going to work with the interface. So now we have to implement them. We have to implement them. So how we can implement them? Now let's say I will create a class hello. What I'll say, I'll say implement one. Now tell me why I'm getting the error. Why I'm getting the error here? We up to now we used extends, no? For now we are using implements. Why? What is the reason? Because it is interface. Exactly. Now tell me why the error is coming? Why the error is coming? Why you are getting the error? Hmm? Because again this is which method? Which method? Abstract method. Abstract method must be implemented or not? So abstract method must be implemented. The same reason. What is the reason? Hello must be implemented. Hello must be implemented. Same reason. Hello must be implementing which method? METH. Because this is abstract, no? This is abstract. Am I clear or not? Compulsory. Compulsory, right? Okay. So you have to implement that method. Add unimplemented methods. If I say, you will get method and you can access what? You can access the x and y. You can access the x and y. Getting my point or not? Yes. So in this way, interface is created with data being what? With data being public, static, and final. Public, static, and final. So with data being what? Public, static, and final. Am I crystal clear? Yes or no? Am I clear or not? So in that way, you are working with the interface. You are working with the interface, and keeping in one you are giving to hello, one you are giving to hello, one you are giving to hello in the sense one's properties you are giving to hello, one's properties you are giving to hello. Is that clearly understood? Yes. So that's the way you are going to look at the done. Point is clear. Okay. Now, now let us understand static and final variables so that you can know what is its specialty. Okay. So static variables and static methods. Okay. So whenever you create static variables and static methods, static variables are the variables that belong to the class or can also be called as class variables. Can also be called as class variables. Can also be called as class variables. So can be they can be directly accessed. They can be even directly accessed. They can be even directly accessed by the okay. So they can even be directly accessed by the class name. They can even be directly accessed by the class name. The variables that belong to the class. Okay, so they can be even directly called by the class name. Okay, the memory will become static. The memory will become static. Okay, the memory will become static. The changes made will become persistent. Will become persistent. Persistent means permanent. Persistent means permanent. Okay. The changes will become permanent. Will become permanent. Okay. Right. How, sir? How it is? I'll tell you. Now, a simple example we will go for. Okay. Let us not talk about all this. So, let's say I have. Okay. So, I have a variable int s1 is equal to 1 and static int s2 is equal to 2. Okay, static int s2 is equal to 2. Okay. Now what I'll do is I will have a method. Okay, so I'll have a method which will say system.out.println s1 plus plus, and I will say s2 plus plus. Okay, s2 plus plus. Now I will take this inherit demo id1 is equal to new inherit demo. Okay, right. Then I will go for one more. I will go for one more. ID2 and ID3. Okay, right. So now after the creation, first I will say ID1 dot method. Okay. Next I will say ID2 dot method. I will say ID3 dot method. ID3 dot method. Okay. So ID2 I will say, and I will say ID3. Now if you observe the output, see what happens. Okay, I'll explain you clearly. Now let's see what has happened. Now basically, if at all you are creating variable, who is s1? S1 is 1. Who is s2? S2 is 2. Now when you are creating ID1, okay, so ID1 will be able to access S1, okay, ID1 will be able to access S2. That thing we know. Yes or no? ID1 can, ID2 can, ID3 can. Okay. Now when I am saying when I'm saying id1 dot method, where the call is going? The call is going to here. Now what it says, s1 plus plus. S1 plus plus means what should happen? S1 will become 2. Yes or no? But what S1 will be printed? 1 only. Yes? Yes or no? Okay. Now S2 plus plus. S2 plus plus means S2 will be increased by 3 and S2 will be printed 2 only. S2 will be printed 2 only. Okay? Okay. Right. So 2. So 2 means this value. Okay. Otherwise what I will do is to avoid the confusion, I'll go for 1, 2. Yeah, this one is better because otherwise we will get confused with the same value. Okay. Right. This one I'll remove. Okay. Now, once again, S1 and S2. Now, first, whenever you say id dot method, okay, what is the value in S1? 1. What is the value in S2? 4. Fine. Now, what I told you, this is the instance variable. This is which variable? Instance variable. But what is this variable? Class variable. Okay. This is instance variable and this is class variable. Okay. Now S1 is equal to 1, S2 is equal to 4. Now when you are saying id1 dot method, now this belongs to id1. This belongs to inherit demo. Understand the difference? This belongs to id1. id1's S1, inherit demos S2. Now I said S1 plus plus. S1 value will become 2 obviously. But as the previous value has to be printed, it will print 1. Okay. Now what is S1 value? 2. Okay. Now system.out.println S2 plus plus, obviously S2 value will increase. Okay. Inherit demos, S2 is now 5. But as the previous value should be printed, it is printing 4. Okay. Now id2.net. Now id2 you are creating. Now S1 is back to which value? No. id2, id1 is gone. id1 is gone. See, your class starts at 12 o'clock. So today what is the day? 25th, 25th April. Now tomorrow again you come 12 o'clock, 26. Means a fresh instance. Yes or no? What is it? It's a fresh instance. Getting my point? It's a fresh instance. Means again it's a fresh day. Again it's a fresh day. So means ID1, we are not concerned with ID1's S1 now. We are now working with ID2, no? We are working with ID2. ID2 also have S1. What is that S1 for ID2? Again 1 only. Because it is the instances variable. It is S1's variable, S1's variable, S2's variable. Yes or no? S2, sorry, not S2, S1 only, sorry. S1's variable, ID1's S1, ID2's S1. So I can say that. ID1's S1 updated and gone. ID1 is gone means this S1 is out of scope. Now we are working with ID2. ID2's S1. ID2's S1. Getting my point? ID2's S1. Okay, ID2's S1. Now again you are working with S1 plus plus. What is S1 plus plus now? 2. But what should be printed? Previous value should be printed. Okay, fine. Now S2 plus plus. But what is S2? What is S2? S2 is class variable. It is not the instance variable. We are not worried about ID1 and ID2. We are worried about only class. What is class variable now? Class variable is 5. not 4. It doesn't go back to 4. Static variable means the value is permanent. The change is permanent. The change is permanent. Getting it or not? Change is permanent. So now you have the change. So what is S2 right now? S2 is 5. Now what value will be incremented? 5 value will get incremented. Am I crystal clear? Yes, that is the power of static variable. Yes? Okay. And then again, next call. Now tell me what happens. S1 will become 1. Why sir S1 will become 1 again? Because now it is ID3's S1. It is ID3's S1. Am I clear? Yes, ID3's S1. So now what will happen? Again it will be 2. So again you have to print the previous value. Yes? Understanding my point? Okay. Then you are saying S2 plus plus. S2 plus means inherit demos. Then what will happen? This will become 7, but previous value has to be printed. Am I clear? That is static variable for you. Memory will become permanent. Memory will become permanent. Understanding? Yes. So that's how we are dealing with the static variable. Clear? Okay. So one more power of static variable is you can directly access the static variable. No need of all these things. Okay. So now for example, if I'm saying system.out.println S2, I can access it. Okay. I can access S2. So now if I'm saying system.out.println, okay, inherit demo dot S2, I can access it that way also. Understanding? Yes. Okay. So that is the power of, so that is the power of which variable? Static variable. Understanding? So static variable can be accessed like this also. And static method means the method becoming static. The method becoming static. The method, when this method is there, this is a static method. Now, for example, if I say, okay, let's say this is static method. Okay, static method. Okay, I'll write I'm a static method. Now I will execute this. Now what I can do, I can directly call that. I can directly call. So I can say method. Okay, I can say method. I'm a static method. Okay, I can even take the help of the class name. Inherit. If it is inside the class, no problem. If it is outside the class, you can use the class name. You can use the class name. So this is static method for you. What is this method? Static method. Static method. Static variable and static method. Clear? Concept is clear? Yes or no? So that's how you are dealing with that's how you are dealing with what? Okay. Okay. So what we are doing here at the end of the day, so we are going for method call. Method where the method is getting called on the static. Where the method is getting called by the inherit demo. By the static method is being called directly, and static method is directly being called by the class name also. Clear? Concept is clear? Yes or no? So that's how you are going to deal with the things. Am I clear or not? Okay. So that's the way you are going to talk about. Okay. Next, final variable. So we will talk about final variables and final methods. So final variables, so final methods and final classes. Final classes. So final variables, final methods, and final classes. Okay, now let's create. Okay, let me say final. So once you say final, what happens? So let's say final s is equal to final int s is equal to 1. Okay, now see what you're doing here. You are trying to say s1 plus plus. S1 plus plus means what? Oh, sorry, s plus plus. S plus plus means what? Increasing the value by 1. Is it possible? It is not possible. Why, sir? Because because the final variable cannot be assigned or changed, we can simply say. So cannot be assigned. So you cannot change it. Once you declare one value, it is fixed. It is fixed. Understanding my point? So what is the variable? This variable is a which variable? Final variable. A final variable. Okay, if I have to write a single line for this, final variables cannot be updated. Cannot be updated. Final variables cannot be updated. So final, how will you say just final, that's it. Okay. Next step. Final methods. Final methods cannot be, okay, so final methods cannot be overridden. Cannot be overridden. So final methods cannot be overridden. So what do I mean by overriding? Now, for example, if I create a class 1, so if I create a class 1, okay, so class 1, and I will have final method, final void method. Okay, now I will say extends 1. Now, what is the output here? Cannot override the which method? Cannot override the final method. Cannot override the final method. So final method overriding is not possible. Not possible. Clear? Concept is clear? Final method overriding is not possible. Next step. Final classes. Okay, so final classes cannot be inherited. Final classes cannot be inherited. Final classes cannot be inherited. So you cannot inherit. So what do I mean by that? Now, for example, if I am making this final, okay, if I am making this final, so what is not possible? Forget about all these things. So one inherit demo cannot be a subclass. Cannot be a subclass. Cannot subclass the final one. Inherit demo cannot subclass the final class one. So you cannot subclass. What you cannot subclass? Inherit demo you cannot use one as the parent. Why, sir? Because it is declared as final. Now you understood what are final variables, final methods, and final classes. Very important. So all the methods in the interface are all the variables in the interface are static and final by default. So we told that only right here. So now you understand this interface. Now X is, what is X, sir? Public. Public means available wherever you want. Public static. Static means memory fix. Static means memory fix. Final means value fix. Final means value fix. Static means memory fix. Final means value fix. So in interface, the values must be static and final. Static and final. Is that clear? Yes. So this is the interfaces. Okay. So and we will talk about in the next session how can we access the uh, multiple inheritance, how to access multiple inheritance, and we'll talk about encapsulation. And in our next session we will be talking about packages. It is over, packages concept? No. Packages and access specifiers. Packages and access specifiers. Okay, so we'll talk about packages and access specifiers. And from Monday we will start Java 8. Okay, so while talking about Java 8, I'll also give you the idea on collection. Okay, so we'll not have a new batch for the people. So if I start, that batch will continue with Hibernate, Spring Boot and everything. Okay, so that I will plan. Okay, so tomorrow I will finish packages, access specifier, so that it will be easy for you. From Monday we'll start Java 8. Okay, I'll tell Priya also. Okay, right. Thank you.